There we go. All right. Now we should be good. Okay.
We added ours to the other.
As a reminder, guys, power quizzes. They're happening.
It's so confusing in my head. How do you know which one's the anti-derivative? How do you know which way it's going?
And that's why we do these things.
When it's C-tan, what is it? Like C-tan?
Okay. That's why we do these things, Graham. We do the time now. Okay. Okay. It's just, I mean, besides just sitting down and memorizing it, just keep working it. You know, you also have to start recognizing some of the tricks. Secant and tangent always go together. So if I have an integral or derivative involving a secant, it's probably going to involve a secant and a tangent. Okay. You know, integral derivative of a tangent is going to involve a secant. Okay. Same thing. Cosecant and cotangent go together. Okay. Sine and cosine go together. Okay. So those are things that can help you. So if I see, for example, what's the derivative of the cosecant of x? Straight up like this.
Oh, I've got it.
Is that?
I should immediately just automatically think to myself,
Negative cotangent.
it's going to deal with the cosecant and the cotangent, okay? Because those always go together.
Totally forgot that.
Okay. Everyone got that?
Yeah, nah.
What if you forgot to put the negative signs at half points or something?
Yeah, I don't. I
Like 2.
What if I didn't write the X's?
I mean, it's
that's,
wrong.
That's okay. I
You
mean,
hate when you don't write that.
Because I was kind of confused with the whole U's and X's. So what's the anti-derivative of cosecant?
Oh, let's clear this up.
So it sounds like you're avoiding the issue. You're just
all right.
because you didn't know it. You're purposely not
Here's the
doing
deal,
something,
guys.
and
Okay.
then wow.
Now, I've been fairly relaxed. I've been fairly kind of okay with notation. So, like for example, if you haven't written the X's or the U's or whatever they're supposed to be, I have so far been like, that's fine. Okay.
And that's going to be fine for this quiz.
It would be fine for this quiz. I'm not going to start changing things now. But I am going to start encouraging you all, and going to start being, you know, as we get closer and closer to AP time, I'm going to start being more of a hard ass about that sort of stuff. Okay? It's more just because I personally don't care. I know exactly what you mean, but this is, you know, we're preparing you for that AP exam. So that is ultimately, you know, we got to do things. We got to prepare for that test properly, basically. Okay?
So what's the antiderivative of cosecant?
Antiderivative of cosecant is the natural log of the cosecant plus the cotangent.
We haven't done that yet.
No, we did that one, but that wasn't on the quiz. Okay? That was one of the ones we had done at the beginning of the week. I think Monday we covered it. Okay? Right? You're going to get a sheet from me tomorrow, probably. Maybe not tomorrow, but definitely by Monday. That's going to have every single derivative rule nicely written out in a way that makes sense to us, okay? So, because I know they're all written out in the book, but the book uses U's and V's and things, and people find that confusing. I plan on just writing it out nicely for you all, okay?
So since I failed this one, there'll be more, it doesn't matter.
Oh yeah, absolutely. Okay? Yeah, there's going to be lots and lots of these power quizzes taking place now, okay? We're doing power quizzes from now until we take the AP.
Dude,
And they're always going to be like this. Yeah, I'm not changing any of the material up.
these power quizzes are
Oh. Yeah. This is a printout one.
Hey, can we get corrections on the power quizzes?
We get half points back. I don't know what I'm saying.
No. You gotta take one check. I was just gonna plop it online for everybody. Okay. One. AP question. This is your homework for tonight, okay? So if there's anything else on Canvas, ignore it, just do the AP. I think it just says
Is it due tomorrow?
okay. Yes.
Damn.
Okay. That's it. This was not a hard AP question. Okay. Probably the hardest part of it is actually part C. But you can, I will tell you this with part C when you're calculating the antiderivative. Okay. Dip into, rewrite the natural log. Okay, we showed you in class how you could rewrite natural logs. Use what you know about natural logs to rewrite them. Okay.
I've really screwed
And
myself over.
if you still can't do it, don't worry about it. Okay. But the rest of it you should be able to do. Okay. All right. What we're going to be up to today, again, we're going to pick back up. Okay. Yesterday, I introduced to you the derivatives of the arcsine arc secant, and arc tangent. Okay, I'm going to write those up again. Okay, so the derivative with respect to x of the arc sine of f of x is equal to f prime of x over the square root of 1 minus f of x squared. Okay? The derivative of the arc tangent of f of x is no. Oh wait, the AB question, yes. Is it 1 plus? I always forget.
Yeah, it's 1
Plus.
How? I mean, you don't even know how.
It's just, again, it's not something commonly used, so.
Was any of those on the calculus today?
No. Will it be on the next one? Probably. Okay, again,
We need to go over the
Maybe he's meditating.
how to do the AP? You should know how to do it by now, it's not that hard. How do I find a critical point? What do I do?
Oh, true.
Yeah, and, okay, quickly go over the AP with you. Question, how do you find a critical point? It's what?
That's a maximum or a minimum.
Right, and you find that by?
First
You put it in your calculator.
Finding where the derivative. Yeah, first derivative test.
Thank you, derivative equal to 0.
Or
That's
put it in
critical
your
point,
calculator.
okay? So, how do I find a point of inflection?
First derivative test.
No, it's the second derivative.
Second derivative is equal to 0, okay? So, that's A and B right there. You do those things, you got it, okay? You're not supposed to use a calculator for this one, but I don't care if you like look up a unit circle in the book or something like that, okay? Which you probably want to do simply because it involves trig, okay?
So we take the derivative, and then we take the second derivative. For A, we take the derivative, for B, we take the second derivative. Set to 0, solve.
And for C, you're going to have to look it up.
We're gonna
It's
rewrite.
require you to either rewrite or look up or do something like that, okay? But that's okay. I mean, that's part of learning. All right. Here are the big three that we need to know for the arc sine, for the arc functions. Arc sine, arc tangent, arc secant. Okay? How come I'm not writing up the arc cosine, the arc cotangent, the arc cosecant? Same thing but negative.
Just the negative, man.
Okay? So don't worry too much about those. Also too, these are the three that actually will appear on the AP. The other three probably will not.
Another one.
Okay? Keep it like that. How would these things be used? Again, you're just following along. Okay, guys, they're just going to be like we've done always with these sorts of things, okay? You just apply the formula and work out your answer. So, examples here. If I said, what's the derivative with respect to x of the arc sine of, I don't know, 5x squared minus 4? The answer would be the derivative of 5x squared minus 4, so 10x, over the square root of 1 minus 5x squared minus 4 squared, okay? And that's it, that's your answer, okay? You don't have to do anything else. You don't have to square that down there, you don't have to worry about that sort of thing. Just do it, okay? Probably where these things will get tricky is you might be asked to evaluate them. And then the only reason why it's tricky for the evaluation is simply because there's a lot going on here, okay? And that could be a little problematic, okay? The other reason why it can be tricky to be asked how to evaluate these things is because the arc sine and the arc secant have very specific domain restrictions, okay? While the arc tangent does not. Arc tangent exists everywhere, so you don't have to worry about it, okay? So if I ask you, take the derivative of the arc tangent at phi, you're fine, okay? Arc secant, though, has a set, what's the word I'm looking for? Set domain, okay? The domain of the arc sine, okay, as a reminder to you all, its domain is only defined for all x's from -1 to 1. So if I was doing a calculus problem, okay, and I asked you to find the derivative of some arc sine function at 2, okay, could I necessarily do that? Unless there is some transformation to it, no, okay, because 2 lies outside the domain of the arc sine, okay. Arc secant also has a weird domain. Okay? What do you think the domain of the arcsecant is going to be? Anybody guess? So the domain of the arcsecant is also weird. What do you think it's going to be?
Tangent, secant.
Is it going to be opposite of the arcsines? Yes.
Whoa.
The domain of the arcsecant is going to be.
What?
Oh, it's okay. It still works. Sliding down a little bit. That's what he's saying.
Yeah, it's kind of just off center. It's really irritating. You keep doing things, I'll get it the way you want.
It's fine. It's good now. Okay.
No, but
All right.
You can't pay attention.
Okay. Now, why is this the case? Why is it go weird like that? Okay.
Wait, where are you pulling this?
Domains. Looking at domains. Okay. Where these functions exist.
the domain of arcsine is
How do
always
you know this?
the
Are
one
you just telling us this, or should we know this?
I'm telling you this, but you should also know this from pre-calculus. Okay. So just follow along. Okay. What? Arcsine. Why is that its domain? Think about it. What's the arcsine ultimately? It's a what? Okay, so half circle, but why? What's it specifically? Why does the arcsine exist?
Ellipsis.
It's the inverse of the sine, right?
Yes.
And so remember with functions, okay, when you do an inverse, you flip the domain and range. So the domain of the sine is all real numbers, but its range is from -1 to 1 only. Okay? So the arcsine's domain has to be from -1 to 1. Okay?
And its range is
And its range in this case isn't all real numbers, but it's darn well close. Well, it's from -pi over 2 to pi over 2. Okay, because that's the snippet of the snippet. If we made it all real numbers, it would be a sine wave that does this, and that breaks the vertical line test many
What's the difference between doing a block?
times.
Okay. Parentheses.
So, okay, what? Oh, somebody asked for that. What does the bracket mean?
It's not defined.
Okay, it means it's equal to, right? Includes it. Parentheses means
Close it.
does not open. Okay, closed, open. Okay. Now, so arcsecant, why is its domain so weird? What's the range of the secant? That. Okay, so the domain would have to flip. Okay, and so things like that. All right. The range of the arcsecant is going to be from 0 to pi. Okay, because if you do more than that, again, you get repeating, and it doesn't work out. All right. Basically, if you were to graph it, you would have horizontal axis. Okay? So, everybody, keep this in mind. Okay? When you're doing, these derivatives. Why? Can I do the derivative of something that lies outside the domain? No. Okay? So, if I ask you to evaluate this arcsine, okay? Hayes and Sam, come on. Okay? If I asked you to do something, so if I said, take the derivative of the arcsine at 3, you couldn't do it. Okay? So f of x has to be between -1 and 1 in order for the arcsine to work. Okay? F of x has to be bigger than -1 or 1. Of course. Outside. Sorry?
Can it be 1 without?
Yeah, it could be 1.
Okay, so
It would work at 1. Well, take a step back there. The derivative is going to have trouble at 1. Why? What is the derivative of?
0.
Okay, not quite 0, but why would it have trouble at 1? What's the derivative ultimately based off of?
Power.
Power. Not power, but very first thing we did the whole year. Begins with an L.
Limit.
Limit, right? Remember? The derivative is ultimately based off the limit. After 1, does this thing exist? No, so can I do a derivative at 1? Limit's on one side but not the other, so no. Okay? So for derivative's sake, while 1 does exist in there, you can't do the derivative at 1. Okay? So derivative for that would be open, derivative for that would be open. Okay? Tangent works fine, tangent's everywhere. Okay? Alright, any questions about how these things work now? So really, when you see them, everybody, by the way, okay? It's all just a matter of really, the most you ever see with these problems is just doing a derivative like I did right over there.
Isn't the f of x a y value? Why are we comparing f of x to the domain?
No, f of x is the function in question. Okay? So basically, whatever x's work for that f of x have to be between -1 and 1. That's what we're saying. Okay? All right? Any questions on how these derivatives work? Okay? Yeah, so the thing is, everybody, okay, David, Spencer, pay attention. Okay? The thing about these particular functions here is their derivatives are kind of complex. I mean, they looks like they're hard to memorize because there's a lot of little bits to them. Okay? I will admit that. However, we don't do very much with them.
It's like plug and chug.
Okay? It's exactly just like when we do deal with the problem with these, it's plug and chug. Okay?
It's like Newton Rabbit.
I always feel bad having to teach these, by the way, because if you look at the AP tests, you might get 3 questions on the entire AP that deal with this. Okay, and there's tons of questions, and so it's like, you know, doing all this work for just 3 points, but you know that could be make or break. So, and they could be really sneaky or jerks and sneak one of these into a free response question. If they do that, then you really want to know what this is. Okay, but that's these here. Okay. That also means, hey, if I reverse these things around, I get my integral rules, right? If I reverse this, I get the integral of that. If I reverse this, I get the integral of that. If I reverse this, I get the integral of that. That is certainly true. However, the integral rules take it a step further. Okay? Now, the nice thing about the integrals, and your book will back me up on this, is the only ones you need to know are arcsine, arctangent, and arcsecant. Okay. The other three, while the book goes over the derivatives, the other 3, they don't even touch the integrals of those. Okay. Those integrals. Part of the reason for that is because those derivatives are just negations of these. When you do the integrals of them, they would look exactly like these 3 right here, just with a minus sign out in front. And the way you handle with integrals, you see that minus sign, what do you always do? You just factor that sucker out, right? And so it would just be the integral of this. So, you know, that's part of the reason why. Technically, there is an integral for the arccosine, there's an integral for the arccotangent, there's an integral that gives you the arccosecant. But in reality, they just all come back to these 3 as it is. Okay? So, kind of keep that in mind. All right, now, good news is we're not going to do the integral of the arcsine. Okay? Instead, we're going to do the integral of something, and the answer is going to be the arcsine. Okay? Now, so that means what I'm going to be doing is just flipping these things around, correct? That's for the most part, yes. However, there is a little bit of an extra step involved here. And it has to do with what happens when we're dealing with numbers other than 1, basically. Okay? When we've got a constant involved. Normally, what would we do with a constant? We would what? Get rid of it.
Put it wherever you want. You just slap it at the front.
Slap it on the front. You factor it out, correct?
Slap that on the front.
Okay? Here you're going to do something a little differently because the constant here is going to be in a little different place. This is going to be a little bit more difficult to handle. Okay? We look at these here. Okay? Our first one here is the integral that's equal to the arcsine. Okay? It's going to be mostly that same rule as we saw before. So f prime of x, okay, over square root of f of x squared with a minus sign. Instead of being 1 there, though, it's going to be a constant. It's going to be an a. Okay? And it's going to be equal to the arcsine of whatever f of x was over a plus c. I'm using the f of x notation here. Okay? When you look this up in the book, they use u and du. Okay? I can come through and put an x and dx in here as well. But I'm going to use the f of x here because it's easier for you all. You guys like it more when I say the derivative of f of x is f prime of x instead of saying dx. Okay? So I think this makes it a little bit better. All right? But notice here the big difference there is that's not a 1, that's a constant, and in my answer I'm going to divide the function by the constant. Okay? Everyone catch that?
Yeah.
Okay? So that's the arc sine right there.
Wait, where's the plus C coming? Oh, because
It's an integral. Always plus C.
That's pretty easy.
Okay? Not too bad, right? Again, though, it's a matter of identifying that this is happening. So every single time you have an integral like this, it's a U substitution. Always. Okay? Always. Because you're basically getting it to look like this right here. Okay? So for the arc tangent, what do you think it's going to be?
U substitution.
But what do you think the top is going to be?
F prime of x.
F prime of x. And the bottom? So for the derivative is 1 plus f of x squared, so here it's going to be
A
a
plus
plus
f of x squared.
f of x squared. Good.
Good.
Okay? That's equal to your arc tangent, f of x over a plus c. And the arc, good lord,
It was something
all I can tell you about the, one slight difference here, almost forgot, okay, is that with the arc tangent, that ends up happening to it. You have a 1 over a out in front and the a squared. All right. Yeah, so slightly different. All right. Why is it not 1 squared in the other problem? It's 1. It's 1 squared. 1. Okay. So this one got trickier, okay? The last one, the secant one is a doozy.
So what is he?
And all I can say for the secant one,
Why is A squared?
I'll explain that 1 second, let me finish this out. Okay? Okay, and I should have put an a squared there too. Messed up.
Mr. Dow, you know what I just realized?
What?
Everything you write on this thing is in reverse.
No, it records it normally.
Oh, it does?
Yes. It's done that way for selfies. Because I'm basically taking extended selfie video of myself.
That's pretty
Okay? And so the selfie cameras will mirror image things. And yeah. All right. So secant there, arc secant's a doozy. There's no real easy way around it. Okay.
So we're not gonna do it. She's a real dude.
No, we gotta do it. We gotta know it, but there's no real easy way around it. All right. I want to point out here though, I messed up the arc sign, so make sure you write it down correctly. It's an a squared in there. There's no 1 over a out in front for the arc sign. Okay. That's a good question. Why is there one? Question I should know.
Why?
Don't know. I'm gonna have to look that one up. Okay. Again, I don't. Again, we use these things so rarely that a lot of times, you know, little questions about them become hard to answer. Okay. But these are what they are. Okay. So they're a bit hard to do. However, what you will notice quite quickly, everybody, is that these tend to be ones that I can actually. I'll get these integrals that normally don't have an easy way to solve them, and they end up falling under this under these headers here. Okay, so an example of an integral involving one of these things might be doing something like the integral of. That's a good example. Oh. Might be something like the integral of might be something like this one right here. Okay, so an easy one.
No.
Okay, what guys? Just hush. Easy one might be something like this one right here. Okay. If you saw that, okay, remember,
Arc sign.
okay, it's going to be the arc sine of what?
F of x over 4 plus c.
not over 4, over 2. Okay? Because remember, it's squared, yeah. Okay, it's the same reason why it's not x, it's not the arc sine of x squared over 4. Right, okay. So yeah, this one comes out very straightforwardly to be arc sine of x over 2 plus c. Okay? They're usually never this straightforward. Okay? But that would be like an easy example of one of these things. Note, it's not, note when we're doing dx up there, it's not x squared that I'm taking the derivative of, it's x. Okay? It's squared in these things, and that's what throws a lot of people off.
Wait, how does dx go to x over 2?
Huh?
How does dx go to x over 2?
2 is the formula. You're just following the formula, dude. Okay? Yeah, again, these are going to be tricky, Grant. These are tricky. These are being, okay? But this is it. These are the last rules we see. Okay? Let's look at another one. Hey, guys. Sit. Okay? Okay? Now, this one right here, oh, square root, sorry.
Wait, but why is
No,
this?
no, because we're doing tangent, excuse me. Okay?
If we follow the formula, wouldn't it be 4 under it?
No, it could be 2. It's just be root 2 when I put it back in.
So
Okay?
you really put root 2.
And so,
Or you
good.
root
In
4.
fact, that's exactly how I ought to write this thing out.
Root 4.
Not root 4.
Root 2. But
Root
4 is
2.
what's under the thing.
Right here?
No, up.
No, up, don't ignore up.
No, but why is there 2?
Okay, so if you wanted to, yeah, because the square root of 4 is 2. So you want to put root 4, that's
Good,
fine.
put root 4.
Could put root 4.
I'm with you, let's move
Okay.
on.
So this one right here,
Root 4 and 2
here's
are the
why,
same number.
here's why you might want to do this differently. Great. Okay? With this one right here, we have a 2 plus 9x squared. These things in the bottom are squared for when it comes to these formulas. So I'm going to write this instead, the integral of dx over root 2 squared plus 3x squared, like so. And that's closer to, I should be able to look at that now and be like, thing squared at the bottom, 2 things squared, this is going to be an arctangent.
Why root 2 squared though? Because the formula doesn't call for those things at the bottom to have square root.
It calls for them to be squared. Okay?
Yeah, it calls for them to be squared.
Squared, right? Well, that 2 there has to be of the number squared. It has to be a squared. Okay?
Yeah, which is 4.
No. It's already been squared. Okay? But it's written out. It's not saying square it, it's saying it's already squared.
So that's
So how do I
that
do
2
it?
is that squared thing.
Exactly. Better now? That's why I rewrote it out here.
Holy crap.
Now, if I did this, by the way, what do I have to do here to make this work fully? I have to put a 1 out front. Not 1 over a. I will do that when I write the final answer out. But, is that x? 3x. So what do I have to add to it? 1/3. Okay.
I don't want to go on a schedule on outside. That's what it is.
It's not working.
That's what I heard it is.
I'm not doing it.
I've got on good authority though that they need something in my hand.
It's because you want to say you just appreciate it.
I thought it was on live on Netflix.
I started watching that in Congress.
Phenomenal.
Oh, really?
I've heard the acting.
Okay, so really don't.
Can you go forward now, Michelle? Whatever else is done.
Hang on.
I just.
When Jose's done, I'll move forward.
Hey, do you have a flip chart?
I don't think I actually do. I haven't had, my cough has gone away. So I haven't had the cough now for about a week, which is nice.
What?
I'm good.
Let me go through.
Although I woke up this morning and my nose is like, well, and it's like, the cough got replaced with a sinus infection.
Joseph, can you hit the upward arrow?
Oh, you finished?
Yeah.
Okay,
thanks.
I'll take care of it. Right there?
Yeah.
Okay. Yeah, these are going to be tricky. We're going to spend basically the rest of the week covering these things.
Are you participating in Wood Break Festival?
Yes. Generally speaking.
When I
You're
get
supposed
this,
to. I'm actually running something.
Don't you think it's like waste of time?
What, Woodbury Cup?
Yeah.
How dare you?
It's all.
How is it a waste of time? Do you want to go to afternoon classes?
No, but like
So how is it a waste of time?
I don't want to be.
He wants the free time.
Yeah.
Okay, well, you.
Here's the thing,
That's
like-
that would. You want the free time, but that just wouldn't happen. You would have to go to afternoon classes.
This is something like Woodbury Cup is a work in progress that will get better and better and better as years go by. So this, remember, is the first year, so that's gonna have some
Actually
quirks
like
and
it
have
so
some
far.
hiccups.
That's true.
It's,
It needs more buy-in. I feel like.
and that's the problem.
And you were not buying in. You were the freaking problem. You gotta buy in.
Alright.
I'm not being mean.
Telegram.
I'm just sticking it up for
See
you.
you.
Buy in, Jap. I know I'm mean, but I'm convincing.
Think it was the Dowell.
Yeah.
See you, Graham.
That's the problem. You can't have.
Oh, Graham. I'm bought in.
Hey, you can't have it. They're like, oh, what the free time? Well, that doesn't even enter in. They wouldn't just give you free time.
Yeah, just your
It's-
other
Woodbury Cup or classes.
classes.
It's just a stupid argument people try to make.
And the Woodbury Cup, like, it's great, really. It's just, I think my big problem right now with Woodbury Cup, the thing that I don't like about Woodbury Cup, and is not what you do in Woodbury Cup. I don't think we spend enough time on Woodbury Cup.
Yeah.
I think if you wanted Woodbury Cup to be more successful, and you wanted people to buy in more, you'd have to dedicate more time to it, not just these events that we do, but actually what I mean by time is actually say, hey, like my team, the Rapid Ed Regiment. Rapid Ed Regiment, you know, like one dinner evening, like 1 week, or like one day every week, Rapid Ed Regiment has a meeting. Where they sit down, they do stuff together, okay? Just the regiment, because the idea is, it's supposed to be a house system, right?
That's how it was in South Africa when I was over there. Every morning, you wake up every Monday before classes start. You have a meeting with your house to discuss whatever happened previous week, whatever happened this week.
And if we did that, Woodbury Cup would be great. And I noticed the events in which we have meetings before we start doing this stuff have been wildly more successful than the events that hasn't happened.
I'm nervous about this thing today.
I think today's gonna be great because you're meeting for it. Teams will.
I see if kids start leaving and they go back to the rooms, just specifically because they have the same attitude as Daniel and say this is a waste of time, then I'll let the smart kids handle it. It's just, I worry because we were sitting in the meeting a week ago, 2 weeks ago, I can't remember, and Mr. I was a huge supporter. I said this is a great idea. But then someone said this could be impossible to plan, and if it's not well planned, and I hope Mr. Al would keep me kind of in the dark, if it's not well planned, because I said if we can't plan it, then we might as well do round robin basketball, airband competition in the art center, and then a spelling bee too, all going on simultaneously. If we can't plan this thing, and kids aren't bought in, then it's not going to be good. So I really hope he did well. He was excited about it. So
I think it's one's gonna be one of the better ones. I think when people actually hear what they're gonna do, you know. Now I think some of this seems a little hokey, but
yeah, you looked at it. I've been completely kept in the dark.
yeah, I'm not supposed to tell you details.
Well, I'm not.
I know,
Yeah.
but I'm still not supposed to. It's supposed to be surprising. All I would say is it should be a lot of fun.
So you are a part of it? Kids
Oh
that
yeah, I'm
go-
doing the thing for this. So I'm not gonna be with my team instead of running up the.
Yeah, that's cool.
It's gonna be cool.
Yeah, we'll see.
I screwed up the rest of the home and I needed for it, but I'll have time between lunch and before this thing begins to make it home.
Wait, real quick, where are we gonna go 3DX from?
The 3DX. Okay, so when I wrote this thing out as root 2 squared plus 3x. Sorry, hang on. Okay, the rule we have works for x. okay? That's 3x not x, so it's a u substitution, okay? And so u is 3x, du then would be 3dx. So that's why there's a 3 up there now,
Okay.
and the 1/3 on the outside, okay?
Okay.
Yeah, we're gonna do one of these, we're gonna do more of these.
Okay, yeah, I see it now.
Also too, I think I'm gonna make sure the homework, let me double check on Canvas.
Is it root 2 squared just 2?
Yes, and the reason I wrote it that way, Graham,
Yeah, but why did you write root 2 in the next part of it?
because root 2 is, we don't want it squared in the next part. The formula is is 1 over a,
Yeah.
not 1 over a squared. And so, yeah, that's why these things get, these get particularly, yeah, this is the only homework for tomorrow, is this stuff. These problems get particularly nasty. They're just flat out hard, okay? And the reason for it is, simply put, it's just a matter of seeing how the formula is, and it's, you know, it's just, this is,
And then the 3x comes in on the top because the last part of it, that last 3x?
oh, again, part of the formula. The formula for the arctangent is 1 over a arctangent of f of x over a, okay? And so we had to, basically when you do these things, you have to recognize where are the pieces of it. That's what we did in our first step. That's why we rewrote it as root 2 squared plus 3x squared, okay, from our original 2 plus 9x, okay? Then you have to actually take the integral of it, which means
U substitution.
you can do a u substitution, you have to do
So how'd that come to 3x though? Oh, because we said u equals 3x. Alright.
Yes.
Okay, but how do you get in the numerator?
What, at the end there?
Yeah.
Again, part of the formula.
Ah, 3, okay, so 3x equals f of x.
Yes.
Okay.
In this case. Yep.
Can I come in, F period on Friday
Yeah.
to take my test, not a consultation?
Oh yeah, retake, yeah, test period Friday, certainly. Which means I have to actually write this test out. Sorry. Maybe I'll still be easy to say test.
Oh, that was sweet. Except add, and then but like do the same kind of thing,
Oh yeah, no,
and then add a couple stuff in the power quiz.
I find it funny sometimes what will gross people out. Because last night, one of our pet cats came trotting home with a dead mouse or shrew or something in its mouth and plopped it on the back porch. And then the other cat came over, saw it, started playing with it, and then picked it up and took it off someplace. And my wife saw this happening and was just like, ew. It's just like, they're cats, that's what they do. when you agree to have cats.
Yeah.
Oh, I've recorded all this.